let's talk about algebraic terms. So for us to understand how many terms are in a specific expression, we need to understand what is a term and what's the basics of a term. So a term can either be a single number or letter, for instance, -3. That's a single number or letter. Or it can be the product of numbers or letters. For example, 2 times x times y. This is the product of 2x and y. So this will be one term. Or it can be the quotient of letters. So this is a combination of product and quotient. So it's d times y over d times x. So this will be considered as one term. In order for us to see how many terms are in an equation, terms get separated by plus or minus. In this case, we've got a single number plus a single letter. That means we've got 2 terms in this equation. Over here, we've already dealt with this. This is the product of 2xy, therefore 2xy is one term. This is the product of two sets of products, if I can put it like that. So it's 89, the product of 89CD, times the product of 3a. So all of this will be one term, as there are no pluses and minuses that separates the 2 terms. This will be one term as it's a single numeral. Over here, we've got the product of 2 and x minus the product of 3 and b. So 3 and b and 2 and x are 2 separate terms. It gets separated by the minus, and therefore this is considered to be 2 terms in this equation. Then over here, we've got dy over dx. This is the product of dy over the product of dx. This is considered as one term, as there are no pluses and minuses that separates the numbers. On this side, we've got a over d plus 5 over d3. Here we've got the over here we've got the quotient of a and d plus the quotient of 5 over d3. So this means that this is a term by itself. Remember, in the beginning we said it can be a single numeral or letter, or the product of something, or the quotient of something. In this case, this is the quotient of something, and this is the quotient of something, and it gets separated by a plus. So therefore this is 2 separate terms.